Hi, in this video, we want to take a look at plotting bnlearn models, and we want to do it a little bit more advanced than the default ways that automatically come out of the box with bnlearn. So one of the major things that is kind of the spur in my side about R is that there are tons and tons and tons of different packages for graphical models, and each one has its strengths, each one has its weaknesses. And if you're going to be using graphical models a lot, you need to get proficient at quite a few of them. And this is a good example of that. So in this lecture, we're going to use bnlearn to build a model. We're going to use the graph package to convert the model to another format, and then we're going to use Rgraphviz to visualize the converted model. So that's three right there, just for the goal of learning a model and then plotting the model. That's all we want to do. If you're going to be working with graphical models in R, you're going to find that this is kind of like a reoccurring theme, that there's some aspect of a model that you want to pull out, and another package is in a better format, or it better supports that goal. And what you typically need to do, you need to find a way to convert your model into a format that will accept. Unfortunately, since R is open source, there are tons of special formats floating around, and different packages have different special formats, and we need to be able to move between them. This is a good example of why SAS is a good platform for doing statistics and data analytics. Okay, now our goal is to make a highly compelling visualization of our graphical model. That's what we want to do. So one of the great things about Bayesian networks, one thing that's great about directed acyclic graphs, is that they're visually compelling if we take the time to build up the visualization. And that's what I want to talk about today. If I use the default ways that come with bnlearn, the Rgraphviz part that comes automatically with bnlearn, that's going to work out really well for us. It does a good job. But if I want to tailor it, I really want to leverage some things, I really need to completely get out of the bnlearn package world and get into the graph package. Good visualizations can make or break your project. You need to be able to convince people of what you're doing. And I found that Bayesian networks, because they're easy for people to visually look at, are very compelling. All right, so for this example, what we're going to do, we're going to take the alarm data set. And the reason why I picked alarm was because it was convenient and it's not too large of a data set. So I was able to play around and work with it quite a bit. The features in the model, features in the data set, I don't really care about for this lecture. I just care about getting that visualization. The principles here really will apply to any model that's built in bnlearn. I go ahead and I build a model using the hill climber algorithm. So, I find that this is one of the best ones to use. All right, so when I do my visualization, actually, I'm going to skip ahead. We're going to go ahead and peek at the end result to see what we get. Okay, so here's my model. Now, in this format, because I'm using R Markdown and I'm passing it to Word instead of PDF, it's kind of hard to see, but for each variable I have a node. And you notice that I colored all of the nodes. And then I made arcs, the arcs going between nodes. I also colored those. I have different shapes on each node, and I have labels on each arc. All right, why is this important? Well, when I have multiple ways to do visualizations, something that's a good idea is to try and double up your attributes for the same variable you're trying to show. So let's say I have, 3 different types of variables in my data set. And what I could do, I could use 3 different colors and 3 different shapes on those variables. I match shape to color, shape to color, shape to color. And that way I'm using shape and color to convey the type of variable I have. I find that this works out very well. You want to it is a mistake to try and show more information in your visualizations. What you want to do, you want to find what is the most important, and you want to put multiple attributes on that thing that is the most important. Okay, so what I've done here, I went ahead and did a fill color. And the fill color for this one, because we don't really care about the alarm package or alarm data set, I just went ahead and used the Rgraphviz color palette and filled it in. I really don't care what the colors are for this project. But if I had specific features to my variables, I would want to group them, give the groups the same color, and then I give the groups the same shape. So that way, so all variables in one group get the same color, all variables in the same group get the same shape. That way I'm emphasizing what's most important. Now, something I've found from personal experience with this is that these circle nodes take up a lot of space vertically. So if you don't know what to do, if you need one to skip the circle, go with box and ellipse, because what they'll do, they squeeze down like this, and the words can fit, and you're not taking up a bunch of dead space vertically. I find it's easier to get the visualizations to, or get to zoom in on what you actually want to show. You notice I've got circles in here, and this could be a little bit easier to read if I would have just used ellipses or boxes throughout. And now you'll notice also something that I did was I colored all of the arcs with the parent color node. All right, so that makes it so that when it gets more complicated and I'm looking down here, I'm looking through, it's easier for me to figure out, all right, which types of variables are predictors for individual variables. This is something I find to be very successful in making the variables. Also, I want to label all of my arcs if I can. And here, all I have is just the parent and the child nodes. Parent, tilde, child. That's how I have all these labeled. If you run the code on your machine, you'll be able to see this. Now, as I look through, when it gets cumbersome, when it gets complicated, and graphical models can get very complicated, it's easier to find what's going on if I label my arcs. And I choose to have the same color arc as I do for the font. That you don't have to necessarily do that. The default for the font is black. And I find that the black stands out more, but when it gets like down here, when the labels start getting close to each other, it's harder to tell which one matches to which one. So I choose to go with the same colors, but it's up to you. And I mean, I am really disappointed by how this looks in Word. If you run this on your machine, it'll be a lot more appealing. All right, so let's go through. All right, the node attributes. If I go into the Rgraphviz package and the documentation, I will find that there are a bunch of different things I control about the nodes. But really, not all of them are all that useful. What I find to be the most useful are the fill color and then the shape, and possibly color, possibly font color. But I honestly, I like to leave usually I leave the color to be black. The color is the outside border. I like to have an outside border helping it help distinguish the node from other nodes or the background. That's my personal preference. That I find is the most important if you find yourself using yellow, for example, where it's not as distinguished from a white background. And shape is useful. I recommend using both of these to correspond to the same attribute. All right, so something about nodes, when we put this in, we pass this to nodes attrs, and we need to pass it in a named list. The name is the attribute that we want to control, and what we put in there has to also be named. Specifically, if I want the color red for node A, I need to label in the vector red, and red has to have the name A. If I want blue for node B, I have to have blue and then the name B, and so on. So I name the vectors by the node that corresponds to. Something that's nice about this is we don't have to worry about the order of our vectors. So when you have a more complicated coding and you're doing all this stuff, you don't have to worry about, do I have it in the right order? Do I skip something? Did I skip something? Do I only want to manipulate one at a time? This gives us additional flexibility. So it needs to be a named list, and the attribute itself needs to be named the node it corresponds to. Those are the two big things. So it has to be a named list, and the attribute has to be named the node you want it to match to. All right. So what I've done in the code here, I pulled out all of the names of the nodes, and this corresponds to the variables in the model. And then I go ahead and I name it, because here I need to have the attributes need to be named every single time. Now I can pull out arc strength in the bnlearn package with the strength, the arc strength function, and I just pass the model and the data, and it'll give me a 3-column matrix, excuse me, data frame with from, so for the parent nodes, to for the child nodes, and then the strength. All right, so I find that this is a convenient way to grab all the nodes and all the edges inside a bnlearn package model very quickly. Now, in nodes tells me how many nodes I have to work with. All right, now here, what I'm doing is I'm telling the Rgraphviz color palette to generate a color for each node. So in nodes is the number of nodes, and I'm going to call that the fill color vector. And then remember, I always have to name the attributes inside the list. So I go ahead and do that. Now here, also the Rgraphviz color package is a good choice because for those who are colorblind. It makes hue, color along the rainbow, and intensity all along the same spectrum. So it's easier to interpret if I have like continuous data, if that was important for the project. Now for shape, Rgraphviz has a whole bunch of different variations on box. It's got rectangle, it's got rect, it's got box. I think there might be another one in there. I just picked box because it has few letters. It's got circle, it's got ellipse, it's got box, and it's got polygon. And I played around with polygon a few times. I really didn't find it that useful, so I usually don't use it. In my work, usually I go with ellipse and I go with box, and I don't use circle because of the excess vertical space that it takes up, but you might want to use it down the road depending on your situation. And so for each node, I need to have a shape if I want to do something other than the default. The default is ellipse. And so here I just went through and, went circle, ellipse, box, for each of them, basically going along, the list of nodes. Now for edge attributes, everything is pretty similar to the way that things work with nodes, but there's a naming convention on the edges because I have parent node, tilde, child node. That is the main difference when I name things. I have to go with this convention, parent, tilde, child, when I label an attribute for the arc it corresponds to. The 3 attributes that I find the most useful for this are the label, the color, and the font color. So the color is the color of the arc itself. The label is the words going with the arc. So approximately, on the halfway point of the arc. And then the font color is the color of that label. And that way I can convey information about this rather easily. So I needed to pass it, everything needs to be passed to the edge arters parameter. It needs to be a named list. And each of the attributes need to be named themselves. And the vast majority of the edge attributes are passed to it in a vector. That's not 100% true, but for the ones that are the most useful, in my opinion, we're going to be using vectors most of the time. Weight is a counterexample to using vectors, but I don't find that to be very useful in the visualizations. All right, so when I do this, the Rgraphviz package will not take a bnlearn model directly. What I have to do, I have to convert it to another format. Okay, so fortunately, the bnlearn package gives me a function that automatically does that. And so I just go ahead and do it easy peasy lemon squeezy. Now, the next part has a huge impact on how your visualization will be received. We have different layouts. There are 5 of them. Each layout has advantages and disadvantages, and you need to make a choice on which one you're going to use. The most important thing I can recommend is be consistent with your audience. You give a presentation with one version, next week use the same layout. In next week after that, use the same layout. Don't jump around on your layouts because they'll be expecting the way you did it before. So even if you didn't pick the best way the first time, be consistent. Your audience will appreciate it if you're presenting to the same people over and over, which is common when you present to decision makers. All right, so the default is dot, and my opinion is that dot is the best one for most situations. It's the one that works the best for my personal work. The other options we have are Neto, 2Pi, Surco, and FDP. And all of these have advantages and disadvantages. Now, the code, the remaining code chunks that we have for this lecture are basically the same thing, except I'm changing the layout parameters. The layout parameter is the Y. All right, so X is the model I want to plot, and it has to be a GraphNL object. Y is the layout. Here I put the attributes parameter here, just so you know how that would work. I usually don't mess with this too much. I find that the defaults are good enough, but there are global attributes that I can use if I choose to. And the Rgraphviz help documentation lists all that out for you. Here are the node attributes and the edge attributes. So the thing I want you to notice very clearly about the node attributes is that this is a named list. So, all right, something I've been noticing in the homework, students don't want to use lists. I understand. I was really resistant to using lists when I was a student. When, actually professionally, I would say the first year that I worked with R, I wasn't using lists. Eventually, I broke down. I started using lists when my projects got too complicated to do otherwise. Using lists can clean up your code. You can make it easier to read. You can make it so that it's easier to update your code. It's more compact. You can make it faster if you choose the right functions for things. I really suggest you start playing around with lists and getting comfortable with them. Here is a good starting point, is that if you want to make a good visualization, you have to play around with a list. All right, so let's look at the dot representation. All right, so what's going on here is everything's going downward. Parents are above children in the node structure. So here, in terms of arcs, we're always going downhill. And then the arrows go downward. Here goes down, goes down, goes down, goes down, goes down, goes down, goes down. And we see that there's a flow. Now, from a conditional probability point of view, we really don't care about the direction. Honestly, we don't. Because of Bayes' theorem, the probability of A given B is proportional to the probability of B given A. If I know A, I can figure out I can figure out conditional probabilities of B. If I know B, I can figure out conditional probabilities of A. And so this is where Bayesian networks become very powerful because I don't need a lot of attributes. So if I need to know about this node and all I have is information about this one, conditional probabilities go up and change this. Conditional probabilities go up and change this. And then conditional probabilities go up and on both of these. And so what ends up happening is that the conditional probabilities on these two tell me the conditional probabilities on these two, because that's all the information I have. And that changes the prediction that I get. So I can always make a prediction with limited information. If I have no information, what it's going to do, it's going to take the marginal cases and give me predictions anyway. It's going to give me the best information it can give for limited information. And this is where Bayesian networks become very powerful. The one disadvantage about these, though, is that they're very complicated and they can take a long time to fit. And honestly, in predictions, they don't really give you solid predictions. My global opinion of them, if I look at an individual node, it's about as good as a regression model. And regression, as we know, isn't going to produce as good of predictions as like random forest, gradient boosting, or neural networks when it comes to predictions if I have a large amount of data. But we're sacrificing predictions to have a lot more information about a lot more variables. Remember, if I do like a random forest, then I only have one target variable. If I do a neural network, then my target variables are not in my predictor variable set, and so I have to partition it, and I can only have so many target variables. The predictors are treated as known constants. Here in Bayesian networks, everything is simultaneously treated as known and unknown, and so I can bounce between the two situations as I need to very nicely. All right, next, let's look at Neto. And this is really crowded. If I originally wrote this code at work where I have a much bigger screen. If this is on a bigger screen, it's spread out more. It's easier to read. If I wanted to use Neto, I honestly would have omitted all the labels, but I wanted to keep them so that kind of like how things work out. So here things are a lot more compact and it's more zoomed in on the nodes. Now for 2Pi, here's another layout. And we can see that the arcs are crossing each other a lot more, which makes it kind of hard to read. If I would have omitted the labels, it would have been easier to follow these arcs. But by changing the colors, it does make it a little bit easier for me to see which arc is going where and which one's a parent. So previously in dot, remember everything was going downhill. And so I always knew which one's parent, which one was child. Here, I've got arrows going every which way. So if I want to use this model, coloring by the parent helps me figure out where an arc is coming from and where is it going. Now, if the parent and child nodes are the same color, doesn't really help me, but whatever. Now, Surco. This tries to work and put things into a circular manner. For this particular example, for some reason, it put this circle like way off and then put this far off. Kind of interesting. For this particular model, of course, I would not be using this visualization. And then we've got FDP. And this one looks more like most of the graphical models that we see on the net as we float around. We start looking at Facebook connections and stuff like that. And that is all I've got for you. I'm going to go back to the dots display because that's the one I think you should use the most. All right, and that's all I got. I hope you're having a great day. Take care and goodbye.